That's a very good question, because that's something I'm always asking myself, and it's always changing. Every single month I have a different opinion. And so I can tell you what is my opinion right now, and maybe it will be a different opinion in a couple of months. Right now I think what matters the most is the relevance of the technology we are developing. And so from this perspective, I think the artistic aspect is more important right now. Because creating a weird or uncanny technology, that's also when the people, everybody see that, they will question their own interaction with technology. And they will question their own desires of technologies. And that's something today that I think is really relevant. And from this perspective, an art piece in the museum can question more the use of technology than a research paper. But right now, there is also this thing that, do we need to always push technology and technical innovation, or high technical innovation? And that's something that I'm really questioning. That's why I'm trying to exploring, as I said at the beginning of this podcast, new materials and alternatives that might be a bit more sustainable, but also a bit more resilient into the way the robots behave, into the way robots look and feel.
In this podcast, I'm sharing my passion and curiosity for soft robotics, where we share inspiring stories about the work we do and how we can push the limit. I am Marc, and this is Soft Robotics Podcast. Support for this show comes from Science Robotics Journal. I really find Science Robotics to be a great resource for reliable and tangible research where we can really push the limit of the science we do in robotics. Great way to stay up to date with the published article is checking out the released monthly issue. All the links will be included in each episode description. We will also happen to have a regular conversation on the most published science robotic articles, where also you can contribute with your question and thoughts about the research. Thanks Science Robotics for sponsoring Soft Robotics Podcast.
I would like to ask you how you would like to define yourself for the people first time listening to you. How would like to define yourself?
So I have a mixed profile. So I come from a design background, art and design background, and I learned the ways of Fab Lab, digital fabrication. Then I moved slightly to HCI, to human-computer interaction. And during my PhD and my postdoc in HCI, I learned how to work with material, with soft materials, with silicone. And I made several contributions in human-computer interaction, but also in fabricating soft sensors and soft anthropomorphic interfaces. So the core of my work so far is halfway between fabrication, design, and human-computer interaction.
Mm-hmm. Great. So maybe I'm curious to ask you, since you have this different expertise, if you look at robotics, what may be still challenging, or maybe granted challenges, if you look, that's something maybe not connected or very challenging still?
So, to me, one of the main challenge of soft robotic is not the control or actuation anymore, I think, but the challenge is the materials. And I think now we need to move beyond the traditional materials used for soft robotics, which are silicon. Why? Well, I think there is going to be some challenging times ahead of us in the next 20 or 30 years from now. And there are plenty of new materials that are rising, the new fabrication processes. And I'm thinking here of bioplastic or all biodegradable materials. And now the question is how to make soft, elastic, stretchable, or actuated interfaces made of new materials. So I think that's one main challenge, one of the main challenge for soft robotic. I see a second challenge, which is in the look, the aspect, and the design. That's where I express myself more artistically. And I think everything related to bio inspiration, but not in terms of functionalities, but also in look and feel. That's something very crucial for the social acceptability of soft robotic interfaces. And that's something that's some knowledge that needs to be borrowed from art, science, design, and that needs to be embedded into soft robotic research and material science research.
Mm-hmm. I really like your approach, and I think you have this kind of, I don't know, unique touch, I believe, in what you do. I can feel that in your work. But maybe I'm curious to ask you in the first part of the actuation. What, for example, in soft robotics field, we speak about pneumatic actuation. Sometimes it could be bulky. And what's your take on actuation, firstly, in soft robotics? Since your end goal is to create something that can have this connection with human and be socially accepted as well. But in the actuation itself, what's your take on what's actually done so far?
On actuation, that's a difficult question, because actuation, obviously there are several ways to do that, and as you know, every ways have pros and cons. I think pneumatic actuation is very rooted in the field since a long time, and now for sure the pumps and the valves are getting smaller, but the main I would say the main issue we are still facing is the air compressors. We need some we need space to run a pneumatic actuation. Now there are all those polymers that can do shape change. You know, you might be familiar with shape memory alloy that can be embedded into the materials to change the form. That's also a nice way to provide actuation. And what I think is that a lot of work remains to be done into the electroactive polymers. And especially now, to my knowledge, the EAP have been explored well with silicon substrate. But I think the past few years we gained a deeper understanding of carbon, like graphene, carbon nanotubes, all those type of materials that couldn't be done easily before. Now that can be done more easily. They have some interesting mechanical and electrical properties, and mixing that with other materials and biomaterials can lead to new ways of actuation. But actuation is not. I would say it's not something I am personally interested in my research, like the means of actuation, because I rely on the work of others to do that. However, I am collaborating with some colleagues here in Paris, in Université Pierre-Marie Curie, that are developing new ways of conforming and forming the materials to minimize the inputs, the air in flow, the input airflow, and to maximize the shape movement and the shape outcome. So it's another way of thinking the optimization of the actuation by thinking how we can mechanically optimize the shapes to minimize the actuation.
Mm-hmm. Yeah. That's very interesting one. Can you elaborate more here? Because now you bring another element. I would ask about the material, but before going to the material part, now you mentioned the shape or architecture and the energy, if we can say here, the pressure. And I find this interesting concept that to minimize the pressure and maximizing the shape, if I understood. Can you tell us more about that?
Yeah, so it's a work made by Benoît Ormond on what he called baromorphic materials. So it's like optimizing the air channel within the shapes to create some complex volumetric shapes out of sheet materials. So it's really like the movement from one dimension to two dimension while optimizing the input. And that obviously it's some some highly mathematical and highly theoretical work that have their prototypes made physically. And my role in this work is to take these technologies, those concepts, those formulas, and to create objects and interaction out of it. And so right now I am involved in several projects, and one of them consists of making some shape-changing drones made out of helium. I mean, all those kind of technologies that was used before, that were complicated to make. Now we can rethink how to make them, how to build them, thanks to those tools. And there is another challenge in using those optimized technology, the airflows. It's difficult to describe because it's very visual, but basically a shape can be made out of really tiny air pockets, as you know. That's soft robotics. But by changing the localization, the width, the thickness of those channels, you can optimize the shape and the mechanical output, and basically those forms, they look like a maze of lot of channels, airflows, and we are developing some digital fabrication tools to guide designers, to help designers making the shape they want. I mean, all of that is very confusing, but it's some early prototypes, and that's something related to the energy that is crucial for soft robotic.
Great. So I want to go back for your main goal as a designer. Now your goal is to design something, maybe, as we said, connecting with human. Can you tell us more about the design process? What's the first step you're looking for in the design? Yeah. Since maybe the last stage is not considered maybe commonly in soft robotic, but can you tell us more about the design? What's the first thing that's significant to you in the design?
Okay, so my main interest in how I went to the soft robotic fields, despite my will almost, is that so originally I wanted to create some artificial skin for robots and for soft robots. But the tricky part, as you know, is to embed the sensor in the material themselves, because silicon it's difficult to work with. It can tear. It needs to stretch, but some hard component cannot stretch within that. And that was the main challenge. So the thing is, we do know that the human skin, the human body, it is something stretchable. It is something that has embedded sensors, in a way, right? That's our nerves, our nerve cells. And so I figured like that, okay, why not doing biomimetism? Not just to reproduce the mechanical aspect, but also all the sensing aspects, the layers, how they are made, how they are composed, their viscosity, and so on. So to go back to your question, what I'm making in my project is that I'm always using the human as starting point of my research, the human or the animals. So I start by having a deep look at, okay, in case of artificial skin, I'm trying to have a look at how the skin is made of in humans. What are the different layers? What are those layers' viscosities, mechanical properties? What are those skin layers? What are their impact on the sensing? And I'm trying to do that also to look at animals, okay, from insects to mammals. What are the difference? Why do they work like that? And what is the impact of the mechanical impact on the sensing? And then I'm trying to look only at the material aspects. So for artificial skin, the human skin is roughly composed of 3 different layers. We have the epidermis on top. The epidermis, that's where we have to put it quickly, the pigmentation and also the surface textures. In the dermis, we have mainly our nerve cells and all our sensing cells. And then we have this layer of epidermis, hypodermis, which is a mix between muscles and body fat. And basically, you can represent the skin as this sandwich of 3 layers. And so what I did in my work was to systematically try different materials to reproduce the epidermis, the dermis, and the hypodermis. So I started by exploring the top layer, which is, here I'm not talking about sensing, I'm not talking about actuation, I'm just talking about the pure like visual aspect and the kinesthetic aspect, the kinesthetic properties. Because what matters for human skin is the surface textures. It can be the pigmentation. It can be the human hair that plays a very important role both for sensing and also for perception. So I looked at various silicones, obviously, to create this layer. The ways to create some textures that is very human-like. And so once I had this done, I moved to another layer. So the layer under, which is dermis, how to reproduce it, what is its viscosity, its Young modulus, how it behaves to stretch, and how to put sensors within it, which is tricky, as the other researcher might know. And then similarly the hypodermis, which is like a body, like something like body fat and muscles. That obviously it has totally different viscosity. It's more viscous. It has different mechanical properties, and yet it is very crucial. This layer is very crucial for interaction, because if you think of an interaction, if I want to touch an artificial skin, I want it to behave like like the human skin. And how does the human skin behave? Well, if I press it, it's kind of soft, squishy. My finger is inside, or I can pinch it, I can turn it, I can twist it, which are gestures that needs some specific materials. And so this is my approach. And then comes the sensing part. So how to create sensing. And so I looked at the different like nerve cells that composes the human skin. I tried to find the tactile acuity. So how much is needed to sense? Then what should I sense? Should I sense only human touch, human contact? What does the human body sense? So I looked at that. And how to implement that in terms of technology. And here, that's where my designer, my cheap designer side comes in, and I really hate complicated technologies because that's something I cannot afford, and that's something that I found like, yeah, that's not something I want. So I try to look at the ways to sense in our surrounding. And we are lucky because we have a lot of sensing interfaces, and that's the phones that are right there. And so my approach, after dissecting the human body into those different layers, I try to dissect the technology into like those different pieces. And so the skin of the smartphone and the mobile device, it's made to sense, right? The screen. And so I try to look at what type of technology is inside. So it's usually mutual capacitance. So it's a technology that allows to sense human touch. And so what I did, I stripped off some components from a broken smartphone, and I tried to make some PCBs out of that to multiplex the channels and to put that inside silicon. And roughly for a project of artificial skin, I found that if I can put some very cheap, very like easily available stretchable conductive yarn within the silicone, so it's stretchable, so it can maintain the fantastic properties, stretchability and elastic properties of the silicone, and it is conductive, which is perfect to perform mutual capacitance sensing. And so to go back to your question, my approach is dissecting and reproducing both human body and the existing technologies, and I try to combine that in a easy and cheap way.
Interesting. So maybe a couple of questions. The first part of the replicating the different layers of skins, the 3 layers. Can you tell us more about that interface between, because I think in some robotics we still have this kind of issue of the interface between different materials, structure. For you, what's the technique to make sure the interplay with each other or coupled with each other in a way so that you can have a homogeneous skin?
So if you bind silicon on silicon, it's binding very well. So that's not an issue. The issue is to bind non-silicon with hard materials. And so if I want to put this skin on top of another. And so I have 2 main principles that I use. First, the viscosity of the silicon itself. If I use a very tacky silicon that remains a bit like wet and tacky, I can just simply put some artificial skin or some sensing layer on top of a hard part, and it's going to stay kind of stuck there. I mean, obviously, if you remove it, it's going to be removed. But that's something that I usually do. And the second technique, it's directly casting on top of the material and making sure that the hard material has some holes, some mechanical elements that the silicon can grip onto. And that's great because I separate the sensing layer from this like viscous layer. So that's the good opportunity to make the 2 separated, and then I can sandwich whatever material with whatever material. Basically, that's how I do.
Why separated? Can you elaborate more? I didn't get why separate.
Why separated? Because if I go back to the description of all those different layers, that's something I made by stack. I made one stack is the epidermis, the top layer. One other stack is the dermis. And one other stack is the hypodermis, the tacky fat layer. And those different stacks can all have different properties that can be made out of different silicons. They can have different mechanical aspect or visual aspects. And so it's meaning that I can eventually exchange those layers. I mean, it doesn't make sense, but I could do that. And I can also cast those layers directly onto the mechanical pieces. And that's where the fun part begins, usually.
Yeah. I think it was interesting about the sensors because I saw the videos you already did about square lattice sensing, that square lattice. And I want to ask you, since you mentioned you try to understand how maybe the nerve or the sensing in human body or the skin, do you think it has the same architecture, square lattice? And have ever you thought about other representation beyond the square lattice? I will mention something, I think, in one of papers in guest here in podcast, he mentioned that if you use complex pattern, it would be maybe more interesting than a square lattice. And since you have been trying to understand the skin, can you tell me more about that?
That's something I deeply believe too. And something interesting as anecdote is that we have a lot of nerve fibers located at the bulb of our hair, of body hair, of forearm hair. And so that's interesting because the hair grow at random spots, and yet that we have all those nerve cells around the bulb. And obviously, it is much more difficult to make in a fab lab or to make in a very DIY way something with random sensor locations. Why? Because the lattice, it's easier to solder. It's easier to control, basically. And there are technologies, there are ways, and I experiment with them to put some random dots, random body hair, conductive hair, like you can think of that like hair, and to connect all of that in a huge sensor interface, sensing interface, and I could have decent results. But making a matrix takes like 5 minutes, and placing every single hair by hand, it takes a lot of time. That matters to me. Like, so it is possible to make that, and I think we will have a similar tactile acuity, but we could sense, I think, maybe more interesting elements of the environments. Like, but that's something. To me, what matters is the accessibility barrier of the technology, and that's something that I struggled a lot when reading a material science paper. That if it's not accessible with a lab, if it's only accessible with a lab that costs like $1 million, that's not a technology that could be reproduced by everybody. And making something easy, understandable, and cheap, it's also a nice way to give this technology to students, to master students, to PhD students, that will be more creative and have more application scenarios and use this technology onto like different materials and so on. So yeah.
I totally agree with you. When I'm looking, for example, the project Polycenter and how it's maybe open source, I like this way of disseminating what you do. And you mentioned the paper and material science. Yeah, there are some great paper, but sometimes it's hard to replicate. So you don't know how it's done. There's something missing. What is your take on that? Do you envision something to change here?
So that's something we had in mind for Polysense project. So Polysense project, it's basically to make any fabric conductive. So we can coat any fabric with a thin layer of carbon particles. And that the issue my colleague had is that, so usually to make some conductive clothes, to make some sensitive clothes, we can create some matrices, and we have this layer of piezoresistive material within a sandwich of electrodes. And this traditionally it was a textile material called Ionix, I think, and something like 5 years ago the manufacturer stopped to make it. And so there was a shortage, and we couldn't do those matrices anymore. And then my colleague Cédric Honnet, he was really upset about that, and so he took a piece of this conductive fabric, and he went to a material science lab in Portugal, and he said, "Oh, I want to make that. Can you look at what is inside and how it is made of?" And so they had this huge machine that could, the material science equipment that costed millions to precisely look at the amount of molecules, materials, and particles that were inside this. And the trick was there were some simple ways to do that for material scientists that costed obviously a large amount of equipment. And one of the challenge was for us and for my colleague Cédric was to make that in a kitchen, in a fab lab. And then that's how we came up with this simple material solution, mixing I don't remember the chemicals, but iron chloride and something else, whatever. And the whole process, we wanted to make the whole process very simple. Like, you can throw your fabric in a washing machine. You mix with the two products. You mix it for half an hour. You remove it from the washing machine, and then you have some materials that are conductive, that are coated with a thin layer of carbon particles. And so obviously, because some materials have interesting mechanical properties, like a textile, which is woven, so obviously when you stretch it, when you pinch it, it has some piezoresistive behavior that we can use. And so all of that, this whole approach, that's something, just I want to make that clear. It's like it's from a design, DIY, and HCI perspective. And that's not something that we precisely characterize. That's just another tool we want to give to students, to master students, to PhD students, for them to try to use and to explore. Yeah.
That's a good point. Maybe before going to the material, I want to ask you here, because you have been mentioning how to come up with creative solution. And I'm curious to ask you, because I think if you have a problem, for example, whether in the material or maybe architecture, and for example, you mentioned taking the sensing part from the iPhone, for example, old one, and I think that's a creative thing. But I want to ask you for something, a problem, because I think in the fields of robotics, that's my opinion, there's two approaches for solutions of problem. Maybe you have a deeper look and then you come up with really interesting solution. And maybe the other solution, it worked, but maybe not applicable in a sense that you need something, you can use it and be realistic solution. And sometimes, yeah, for example, you try to make something connected with human. Sometimes you try to do something work for maybe, yeah, just short amount of time. So there's different, to be honest, I feel there's different approaches. And for you, the creativity, when you try to find solution, how do you think about that in the field?
So I think that comes to the way everybody should define, like everybody define themselves. And I don't want to put myself within a research field, because being within a specific research field, it's somehow like trying to cut your knowledge from other fields. And so I rely on a mixed research approach, like very interdisciplinary. So I don't want to stop in material science, but I will look at some material science paper, even if I don't understand anything. I'm looking into robotics, traditional mechanical robotics that are very crucial. Soft robotics, obviously, I've been looking in human-computer interaction, in digital fabrication. And I think by looking at all those fields, they all come up with different type of solutions. And that's really what matters. It's the typology that people use to find a solution, and what are the questions they want to solve by their contribution. And by looking at that, you can see that in HCI, the researchers are creating user-centered design tools. In material science or in soft robotics or robotics, researchers are creating their own machine to create other machines. In material science, it's something like really, like to me at least, it's more technical, grounded into prior knowledge of materiality and in the mechanical aspect of the object. And by looking at all that, I try to get to the research methods they use. I try to use the research method they use, and then I come up with ideas. And something, how to do that easily, I'm not doing that by myself, it's just like collaborating. I have colleagues in material science, I have colleagues in like various domains, and by going to conferences, by going out in bars here in Paris when it was allowed, you could have like very rich discussion, very creative discussions. And you could think creativity as a muscle, right? And that's a muscle you do have to train, especially like the young researchers that are listening to this podcast. I think that like every problem is solved by being creative. That's how you solve problem. At some point you need to be creative, and that like training that, I don't know, doing like artistic expression. That's something also that I'm doing that favors this serendipity. And another aspect, how I can come up with those different approaches, is that I'm resigned not to fail. I cannot accept the failure, and I think there is always a way to do something. And if I go back to the project and the sensing technologies that develop, I had like countless failed attempts. I think I have a box full of I think 30 or 40 failed prototype of artificial skin. That some of them were with single sensor, some of them were FSR, some of them used other materials than silicone, some of them used conductive textile. I mean, a lot of failed prototypes. But I keep digging, I keep to try to go around the technical problems I had, and so yeah. So to put it simply, what matters is the analytical skills. But the analytical skills you can develop by looking at other communities, other projects, other approaches and research methods. And that's something important.
That's great. Maybe since you mentioned the process to come up with what you have already now, when you look to the structure, what you did to resemble the human skin, what's maybe missing still? Do you think the material so far is, yeah, you mentioned there's a need to push here, but if you can list the limitation or missing pieces here to resemble exactly what you have in nature?
Yeah, I think in overall in the robotics paper, the tangible aspects is something that researchers do not explore much, and that plays a huge role. Like the tangible and the visual aspect, like when an interface, what does it looks like, how it behaves when you touch it, how does it feel when you touch it. That's something that matters. So for my project, that's why I try to reproduce the wrinkles, the pigmentation, the veins, and so on. In my current prototypes, what's missing is that I still don't have some typical human features, which is sweat, heat, human hair, like all of that you don't realize that is crucial, but when you touch someone else's skin, that's something that you know should be there, and you know it's there. That's some tacit knowledge of what it looks like that you acknowledge. Basically, it comes to the affordances of an object, affordances of an actuated interface. Does it look like an actuated interface? And if I touch it, does it feel like it's something that should look like an actuated interface?
Mm-hmm. Yeah. So what does it take to achieve that? Do you think, you mentioned material part. Firstly, what kind of feature do you think is still missing in the material you're using now? Besides that as well, maybe something beyond the material as well.
So the material, so the features of the material, it's what I said. So to have heat, so there's ways to do that, right? Putting resistance within the materials, putting Teyssier cells within the materials. With like temperature or humidity, there's something much more tricky, because as you know, silicon, it's not like it's it's difficult to create some humidity out of silicon. And that's something that is crucially missing. And for the other types of soft robots that I see in the literature, I think what's missing, it's more like the form, the molding. I put some effort into creating some molds that are not exactly flat, that have some bumps, that have some organic features, and that's something that should be a bit more explored, maybe in the field, because it matters obviously for social acceptability, for interaction, and even for actuation.
Mm-hmm. Great. So I'm curious, in that process, is there something was counterintuitive, the way of the design? If you can share some interesting aspect from the book, you say the failure steps until you get what you have. Is this something was interesting or maybe counterintuitive? Wow, I didn't know that should be working that way. You have this interesting moments or counterintuitive to what you thought should work.
I see what you're saying. My approach is to think of the technology look and feel first, right? And I don't care how it can be actuated. I don't care how it will behave. I don't care how I will characterize it, how the sensor will behave. What I do care is that, does it look something socially acceptable? Does it look like something does it look like what it should look like if I'm making that into a robot? And then as a second step, I'm trying to figure out what is the technology that can be developed to make that.
Maybe I'm not sure if you get my question. I was asking if there's something was counterintuitive to the way of thinking about the design. I don't know if you get
I think that's the counterintuitive part, right? The counterintuitive part is, to me, it's not to think technology first, right? It's to think aspect first. And also, it's to think of the purpose of the technology. And that's something, so I'm not necessarily developing technologies to make some research or scientific contributions, but I also see technologies as a critical design tool to help speculate on the future of interfaces, on the look of interfaces. And that's something that is really valuable into different communities. Is to say, okay, like, you know, that's the typical sentence at the end of the papers, like, oh, we should look deeper in the social acceptability of a robot or whatever. But I'm using that as a starting point and see like developing something like that. I see it's creepy, it's uncanny, it's weird because it's super realistic, it feels realistic, it sounds like realistically. Oh, by the way, it's made like that. But should we have that? And what can we do with that? And what does it mean for the future of technology? And that's where the counterintuitive part plays. So I cannot tell you how my brain is wired. Maybe it's wired in the wrong way, but yeah, that's my approach to design and to materiality.
Mm-hmm. That's interesting, Bart. I want to go back again, this loop, the material, and you have the shape or architecture of the skin, and you have the sensing, and you have the artistic part. So it's component. When you look to them, which one is significant in that case for you?
That's a very good question, because that's something I'm always asking myself, and it's always changing. Every single month I have a different opinion, and so I can tell you what is my opinion right now, and maybe it will be a different opinion in a couple of months. Right now I think what matters the most is the relevance of the technology we are developing. And so from this perspective, I think the artistic aspect is more important right now, because creating a weird or uncanny technology, that's also when the people, everybody see that, they will question their own interaction with technology, and they will question their own desires of technologies. And that's something today that I think is really relevant. And from this perspective, an art piece in the museum can question more the use of technology than a research paper, right? And so, yeah, and so right now that's what I believe. Like a few months ago, I believed that creating some open source tool, open hardware tool for the students and for the PhDs and for the researchers was the way to enhance technology. But right now there is also this the thing that, do we need to always push technology and technical innovation, or high technical innovation? And that's something that I'm really questioning. That's why I'm trying to exploring, as I say at the beginning of this podcast, new materials and alternatives that might be a bit more sustainable, but also a bit more resilient into the way the robots behave, into the way robots look and feel. Yeah. Mm-hmm. But that's
maybe a quick question. Yeah, go ahead. Sorry.
No. I just wanted to say that's something that is always evolving. It depends on the news feed I'm reading, and on the technologies I see that are employed at large scale, and that also depends at where I want to contribute. And basically, it's an ethical question and ethical position that I'm trying to find here. Yeah.
I really like the part when you say that piece of art maybe express more than a research paper. And you're the first one I can hear the statement about expressing that. Aren't you afraid that, because I think maybe it's a majority, the research paper, it's first thing, but now you mentioned something I think interesting. Are you maybe, I don't know, afraid of this way of thinking because it's not traditional maybe?
I could be afraid of how the peers are seeing my work, because it's weird, it's uncanny, and it's unusual, and it might not fit into the research canon. That's something that I could be afraid, yet I am not. Why? Because first, when I released my uncanny projects, and now I have like a realistic human-like eye. I mean that it's really like visual and very strong, very emotional pieces. And so obviously there is a lot of comments online, and I got a lot of like mean comments, or like people asking like, oh, why this guy is doing that, he's crazy or whatever. and from the research peers, I also had a bit those questions for the few years. The first project, the creepy project I made, like people were, why you are doing that, and and this guy should be shot. But now I'm not afraid. I'm okay to fit in not. I'm okay to not fit in any case, like predefined case. Because what I do love about this position that I have right now is that, you know, when people see my work, whether they like it or they don't like it, they have an emotional reaction. And that's something that truly matters to me. And obviously, because I'm a researcher, I want to characterize my technology. I want to disseminate the technology. So I'm trying to I'm making some serious work out of that. So I'm not afraid of being judged because I know that the work, like the technical work behind that is solid. At least I try to make it solid. But you know, it's quite fun. And research is also about fun, right? I want to create things that are fun to me, so I'm making that fun.
Yeah, I agree with you. Yeah. So if you push your left, but I want to ask you, since we have mentioned this component, and the first example we mentioned that the shape and the energy, if you minimize the energy with a shape, if we apply that to the skin here, how do you see you can embed intelligence without using, for example, like complex shape for sensor, whatever, just to be simple and intelligent without many components? So can you see this applied?
Yeah, I really believe in the power of how to say that, of the like all those low power circuits, you know, like RFID or whatever, that and that can use heat, that can use energy made out of friction, out of movement, out of natural uses. And so in this context, I really believe into that, and that's something that will be very valuable for the future of soft robotics. However, I don't see any concrete implementation yet. I have the gut feeling that it's something that we should look more into it from a sustainability perspective, from a material perspective, and for a user interaction perspective. But that's, yeah.
Mm-hmm. Mm-hmm. Maybe a quick question. This is just something before you have been now working many years in this domain, this combining these all together. If there's something you wish to know at the beginning to save the time, to maybe sometimes I wish I know that before and take you a long time.
That's a good question, but you know, I don't like everything or nothing. You know, that I'm very glad to have failed. I'm very glad to have taken like years doing stupid things, because that's part of the learning process, and now that's something I can transmit to the students, and that's how we build knowledge at a society scale. So I never told myself, oh, I wish I knew that before. Also because having some strong a priori about technology and how we should be implemented, how we should look like, that's something that also is driving you away from creativity. And not knowing anything about technology, not knowing anything about research, being naive on some topics, that's where you can make some creative contribution. I'm not saying meaningful contribution, but I'm saying creative contributions. Yeah.
Mm-hmm, mm-hmm, mm-hmm. Maybe two questions left for aspiration. And maybe for aspiration, because you highlight many times the creative part and having accessibility for maybe expensive setup, maybe expensive equipment. Does it change the way of thinking of the design? Because
no, it will not change. Because I'm that's not because I do have a lot of, and here in my lab I do have a lot of expensive equipment. But I'm not making research for myself or for the paper or for the state of the art, but I'm making research for accessibility, for open source, for open hardware, for education. And so that's why I always try to go back to simple solutions. And those days I'm even like exploring the low-tech alternatives. So how can you use technology that are not powered? How can you make some simple mechanical devices that were made with servo motors, for instance. You can make like mechanical version of that. And so I'm even like going back to more simple and again more resilient technologies that are something deeply rooted into the human knowledge for centuries.
Mm-hmm. And what is your aspiration when it looks to what you do now? Do you have any ideas about, I don't know, any other feature or aspiration? Where do you want to go?
Where do
What's
I want
next
to
for
go?
you?
I'm more and more critical toward technology, the way we implement it and the way we research it those days, because it's always not considering the resources we have in the planet, and that's something like, okay, we can think of something that uses an infinite amount of motors, but we cannot build an infinite amount of motors because we have some hardware limits that are the planet Earth, and so I'm really now like I don't know, to be honest. I'm trying to explore new ways of thinking technology, and so I don't see a strong technological development from this point now that is following the same principle of research as we are used to conduct it since the past 100 years or so. So now I'm more thinking into what are the radical ways to rethink the futures, or what are the critical points we should investigate right now to create alternative materials or alternative robots, or whatever, more resilient robots and so on. So again, the future I see, the aspiration, it's not something that is following the current line of research we are conducting, but I want a radical change, something like critical and deeply refactor of the fabrication process or the understanding of technology.
Excellent. Now, I love the question. Maybe if there's advice was given to you and it was a life-changing advice, maybe in the career or life, and stick to your mind, this advice was truly meaningful to you.
I'm not sure I had a strong given advice, but something that stick with me is that's not because somebody told you should not do that or it's impossible to do that you should listen to them. And when I built my project, I had tons of people, researchers, arguing of whether I should do that or not, I should continue exploring, or telling me, oh, it's impossible to create what you want to create. And I kept doing it anyway. And that's something, that's maybe an advice that someone gave me one day, but that's something that really stuck with me, and that's something I want also to transmit and to share. Like even me, I am wrong when I tell my students, oh, you should not do it this way, but they are trying, and usually they are figuring out how to do it. So yeah. And that's something very important. That's something very important. Yeah.
Absolutely, I agree with you. I don't know if you have any final words you'd like to say for people listening or for the philosophy community. Any final words?
Final word, I think that today it's crucial to think of the materiality of soft robotics and the goals of those robotics. And the goals should not be towards like creating new devices again, or like enhancing, advancing the whole human race by introducing new technologies. But it should be more, okay, how we can use soft robotics to create more resilient versions of what we currently have. And that's something that should really matters because well, we have material constraints, the time is pressing, we will face other major issues. And if we have more resilient technologies, I think it's going to be much easier to build and to rethink of the future of manufacturing processes. And that's something that should matter.